My name is Jeff Alderson. I am the Education Product Marketing Lead at MathWorks. I'm responsible for teaching and learning workflow products at MathWorks. You're probably familiar with MATLAB Grader. If you are, that's probably one of the reasons you may have joined today's webinar because you saw MATLAB Grader in the title, creating MATLAB Grader problems using MATLAB Copilot. Other folks that are attending today might have just be thinking about this new product that MathWorks just launched called MATLAB Copilot. And how that might impact your ability as an instructor, an educator, or faculty to create great course content. And that's what we're going to dig into today. And I said I'm joined by Cheryl Chi, who's my teaching assistant for today, to help out with logistics. So we are MathWorks. If you're joining today's webinar, you probably know who we are, at least at a high level. If not, you're an avid user of our products. We are the folks that make MATLAB and Simulink. I'm located in Natick, Massachusetts, which is where our headquarters for MathWorks is. Our products, MATLAB and Simulink, and all the related toolboxes, block sets, and add-on tools are used widely worldwide for teaching and learning. Over 7,000 schools are teaching with our software. About 3,000 of them are using our open access license called the campus-wide license. That includes access to everything you could possibly imagine for teaching and learning, including access to MATLAB Copilot, which we'll be talking about today. There's lots of books that have standardized the content and curriculum on MATLAB and Simulink, and there's thousands of graduates every year that graduate from university to go into the workforce with MATLAB and Simulink skills. And what we're really talking about today is empowering you all as educators to create great learning content and assessments using our products. And so to do that, we have to connect. We're going to talk today about connecting two specific products. First, MATLAB Grader. That's our auto-grading solution for MATLAB code. It's how you tell whether a student's code is correct or not. And we're going to combine that with MATLAB Copilot, which just came out in 25A. And so if you're looking at what version on your desktop or in MATLAB Online, as long as you're using 25A or later, you've got access to MATLAB Copilot on our university licenses. We're going to talk about what that is. That's our tool for generative AI coding, creation, and editing. It does a lot more than just code, as we're going to talk about today. But it really is going to be the place we're going to be spending a lot of our time in discussion today about how to create great assessment content for MATLAB Grader. We're going to talk about at the core what we were talking about with assessment content that's related to MATLAB, where you can create lectures and take your live scripts for lectures and just convert those into autograded assessments. That's at the core of what we're going to be talking about. But then we want to dig in a little bit deeper and say, well, really, what goes into creating a great MATLAB skills assessment? And it's going to come down to something we all know intimately well, learning objectives. But also, we're going to delve into prompt engineering. We're going to talk about what goes into a good prompt as well for creating good assessment items out of MATLAB Copilot. Then we're going to show some advanced maneuvers, some really cool pro tips for getting the most out of MATLAB Copilot to create assessment content for Grader. We're going to talk about unit tests and how they work with functions. We find that this is an area that faculty actually may not even know a lot about, let alone students. And so we want to show how Copilot really makes that a really simple exercise. We also want to talk about a pretty common workflow that you might have as an educator, where you might be updating your content every academic term. And one of the reasons you might want to do that is to deter cheating, so that the content uses the same learning objectives, but it's an entirely different set of assessment items. We're going to talk about how to do that using MATLAB Copilot. And then here's a very common one. Say you've been teaching a course for a long time, and it uses, and it's okay if you do this, right? We're not angry about this. If you're teaching with Python or you're teaching with another programming language, C or something, and you've got a lot of assessment content off the shelf in other languages, and you want to convert that to MATLAB code type assessments, but keep all the learning objectives and the academic discipline intact, we're going to show you how to do that. We've got a lot of tools, resources, videos, content to help you in these workflows, and we'll share that at the end of the presentation. And I'm hoping to leave plenty of time to answer your questions as we go. So what is MATLAB Grader? MATLAB Grader is our auto-grading solution for MATLAB code. It does one thing and one thing very well. It tells you whether the student's solution is correct based on how you, the instructor, define correctness. We have integrations for that with learning management systems. So if you're using Canvas or Blackboard, you can integrate this great auto-grading solution into those assessment environments. But what it's really meant to do is solve this problem. And this is an old-timey photo, but you might recognize yourself in the picture because people, as I'm aware, and I'm told this, reminded of this weekly, people are still grading MATLAB code programming assignments by hand in paper. Yes, that's a thing that are still happening. And there's inherent issues with that in terms of the delay of how long it takes you, or if you're lucky enough to have them, an army of teaching assistants to grade that homework and give feedback to the students. By the time you get the grades back to the students, those students are already on to the next homework assignment, and they may not fully have mastered the skill set. They might be reinforcing some bad programming practices and concepts, and you're never caught up with where the students are in terms of where they need to be in the curriculum. And so what we can do with MATLAB Grader is provide you an entire ecosystem for auto grading, where the students submit their homework in a web browser, they get instant feedback in real time. They can then iterate on their solution, improving upon that, learning and mastering the skills that you want them to have, and then they can move on to the next assignment once they've completed that activity. And then you as the instructor have situational awareness, automated grades going into your gradebook, so you can see what's going on. What's really great about MATLAB Grader also is it's fully integrated with MATLAB Online so that you can get the full desktop experience. It's not just about the syntax of the programming language. Yes, you want to make sure the syntax is written right and the code was correct. But when integrated inside MATLAB Online, you see an environment sort of like this, where you have a MATLAB Grader panel on the left, which is prompting the student to do a certain activity, and then the MATLAB live script on the right where they're actually putting in their code, and a submit button, so when the student's done they can submit their code and get feedback. What's also great about this environment is it also gives you access to all the great features of MATLAB Online, like the live editor, access to the workspace, access to the command window and the debugger. One of the things that we also wanted to make sure of was MATLAB Grader as an assessment product. When used in MATLAB Online, we were anticipating this question. MATLAB Copilot, our feature for generative AI code creation, is off by default for students when they access MATLAB Grader in MATLAB Online. They could go and use, on their desktop instance of MATLAB and pull up Copilot. That's a separate topic. But in the context of assessment, when they're being graded in MATLAB Grader, MATLAB Copilot is off. But they get all this wonderful experience to be able to actually iterate on their code and see their results in real time. They'll see red X's and error messages and instructions from you about how to improve their code. They'll see green check marks if they get it right, and they can move on to the next assignment. And so that's just sort of a high-level overview of what MATLAB Grader is. A lot of people, I think, that are on the call and the webinar already are telling me in the chat that they're MATLAB Grader users, and that's great. I'm glad to see that you're on the call. And today's webinar is really how to take your assignment content creation to the next level, or to help you build assessment items a little bit more quickly. One of the big things about MATLAB Grader to adopt it is you have to convert your traditional assignments into auto-graded assignments, and that might take time. That might take a little bit of effort and energy on your part, and you might want to be able to do some iterations and some testing on it to make sure that the assessment items are correct and aligned to your learning objectives in your course. Okay, so how do you do that? The thrust of today's webinar is we have another product at MathWorks called MATLAB Copilot, which came out in 25A. That is our generative AI solution. So knowing that MATLAB is going to be used by all your students when they go on into the workforce and their careers as engineers and scientists, and we all recognize that generative AI is absolutely disruptive and is transforming how that engineering and science is done, we brought to market an entirely new product built into MATLAB itself, tightly integrated, as you're going to see here, in the MATLAB environment, to use generative AI to improve your everyday workflows in MATLAB. And so that is right available in the ribbon. So if you're in MATLAB and you're on 25A or later, and you've got a license for MATLAB Copilot on your university license, you're going to see all the menu options that you see in the screenshot called Copilot, and you can just sort of get your work done right in MATLAB. But let me break it down for you. Let me talk to you now about all of the features of MATLAB Copilot that we're going to use when we talk about creating assessment content. First off, you can just sign in. When you sign into MATLAB Online or MATLAB on the desktop, you're going to see this Copilot Chat. I think it actually opens up by default now to give you an idea that it's there. And you can see there's a button in the top right-hand corner where you can actually, access the chat anytime you want. It's a typical generative AI chat right inside MATLAB. So you can ask it anything in the form of a natural language question, and it comes back with some results. Which some of the features of that is that there's code. If the code is included in the chat response, you can, with one button click, run it on the command line and see the output. You can also move the code over to a live script to work with it more directly. It does a lot of really great follow-up references, so it'll show you with the authoritative sources about how it reached the conclusion it did in the response. That's very useful for instructors that want to tie off the chat conversation to official documentation or teaching and learning resources. And there's also really great follow-up prompts. So if you're asking questions about controls, it might start to recommend other topics you might want to drill into specific controls theory. And in that, it's going to be a feature that we're going to talk about as we discuss creating MATLAB Grader assessment items as well. Another feature of MATLAB Copilot is that we have autocompletions inside the live script itself. And so at any point in time, if you're looking at a live script, and I'm a Mac user, so I hit Command Shift P, I can, get a prompt to actually create code. But we also have autocomplete. So if you've been using autocomplete with live scripts, it's now fully enabled with Copilot. So as you hover over areas of your code, if you want to get autocomplete suggestions, you'll see we call them little stars, the little twinkle stars. You can then, anytime you see that, Copilot's being involved. And you can hover over your code and do autocomplete. Or you can hit Control Shift P, or Control Shift P on Windows, Command Shift P on Mac, and you get a little prompt right in line to your live script. And so you can highlight code, Command Shift P that, and then get a prompt to ask Copilot to do something. Or you can right click the code, go to Copilot, ask Copilot. And in this case, I've just really asked Copilot to swap the placement of the variables on the plot. And you can ask that in natural language. It updates the code you'd highlighted, affects those changes in the code, and you can choose to accept those changes, diff those changes against the original code, or just discard them and move on. So inline auto-completions, inline asking Copilot to do something with your code, very powerful tools. We'll be talking about that as well. Another feature is built into the product is explaining code. So you could be in a live script, see something complex. In this case, it's regular expression. I always have trouble with regular expressions, not just about MATLAB, but just in general. I just don't quite get them. And so you can basically just highlight a line of code and right click it and say, please explain this. And MATLAB Copilot will actually give you a lot of good detailed explanation about what's going on in that particular line of code. And it doesn't just give you like the doc on the function regex. It's going to actually do more than that. And so what do I mean by that? It's going to show you what the line of code is. In this case, it's a regular expression and what it's meant to represent. And then it unpacks for you how it does it. So this is actually really great for student use, maybe more so even for instructor use, although anyone can use this capability. It's meant to show you, really what's going on in the code. So if you hand out lectures to notes to students in the form of live scripts, students can just right-click the code and get explanations about what's going on. If you're writing up syllabus, you're trying to write up good explanations for lectures, you start with just working code. You can right-click on it, have Copilot explain it. This becomes really great content you might want to use in a lecture. It also becomes really good content you might want to use in an assessment prompt, and we'll talk about that. So here's the other. So this feature is right-clicking to get an explanation of code. Another feature is generating comments. So using that same bit of code here with that regular expression, I can highlight that code, right-click it, or go up to Copilot in the menu and say generate comments, and it will use everything it knows about functions and this particular regular expression, and it will actually create all the comments that are needed for the function. Now, what's brilliant about this is that it will actually put into the comment the right format that you would expect for the help feature of MATLAB. So now you can do a help call on that function file and get back information about the input and output arguments and what the function's supposed to do. And so it really encourages you to model best practices for students. If there's a common thing that we all do, which is we should be doing, documenting our functions, this makes it right-click easy to do that. So I highlight this as something that you might want to use as you build helper functions for students. So if you're creating assessments and you want them to call your functions as part of their the student's work, you might want to make sure you're properly describing those functions to help the students use them in their coding work. And this is just something you can do very quickly as an instructor. Just highlight that function call, generate the comments, and that's why that might be useful. Moving on, this one we're going to spend a lot more time with in the context of assessments, but it's generating tests. So if you have a function, so again, using the same function that converts numbers to strings, I want to create test cases for this. I want to make sure this works for different types of numbers, positive numbers, negative numbers, large numbers, all those things. And so you used to have to write assessment tests, unit tests in MATLAB by hand to test all those cases. And so we make it one click easy now. So if you've got a function and you can call it and you can test it with certain input numbers, in this case, 1e⁶ is going to give you 1 million formatted properly, but I want to test it on all sorts of different possible combinations. All you have to do is, while you're looking at a function file, go up to Copilot and generate the tests. And it will think about it for a little bit, and it will come back with a complete set of unit tests using the MATLAB unit testing framework, and one test case for each one of the sets of inputs, arguments that are expected, and then comparing it to what the actual number should be. And then with one button click inside the unit test palette inside the editor, you can just run the tests and then see the output and the results of that. So if you're writing functions that get included in student assessments, or if you want to model good behavior for students, this is actually a really good feature for students that are using MATLAB online or MATLAB on the desktop as they're writing their own functions as part of solutions for assessments. If they have access to MATLAB, they have access to all these capabilities. They can actually use this to actually evaluate their own functions before they submit them as part of the homework. So it's a really great tool, and it's as easy to do as just right-clicking code and generating those tests. All right, so that's a review of MATLAB Copilot. And we have a lot of resources we'll share at the end of the presentation about both MATLAB Grader and MATLAB Copilot if you want to go in depth. And this presentation is not meant to go in depth on those features, but how these things work together. So let's talk about that. The real thing that we're trying to do is take code you may already have or that you're going to generate using MATLAB Copilot and convert that into an auto-graded assessment item fit for purpose for MATLAB Grader. We have a really great video. One of my colleagues, Bradley Horton, has done a really great job of unpacking the step-by-step of what makes up a MATLAB Grader problem. It has a problem description. It has a reference solution, which is like a correct answer that you might prescribe for the student. It has a learner template, which is starter code that the student might start with, or nothing at all. And then one or more assessment tests that are going to run. And the way that MATLAB Grader works in its essence is it runs the reference solution, it runs the student solution, and then it compares those two solutions' outputs using the assessment tests. That's it. And so we want to be able to make sure that you, as an instructor, can use MATLAB Copilot to look at existing MATLAB code or content you already have, or that you find online through our tools and website, and convert that into the parts that you need to put into MATLAB Grader. That's really what we're talking about. Okay, so what do we mean by a great MATLAB skills assessment? So MATLAB Grader is a really great general purpose tool, but what makes it powerful is that you as an instructor bring into it your own knowledge about the academic discipline. And when I was in grad school learning about education and teaching, I think I spent more time on this topic than anything else, because it was drilled into me that this is what we as educators need to focus on to make sure that we're teaching the right things and can assess that students have mastered the right things. And so I apologize if I'm going to be going down triggering folks in terms of going back to thinking about how we learned about how to teach, but it's all going to come down to learning objectives, right? A well-written learning objective is at its core what we need to build a great assessment. And so just to remind us all about what goes into a great learning objective, I think we're all familiar with this, the A, B, C, Ds. We'll talk about that. And then the other part of what we need, particularly if we're going to create those assessment items using generative AI, we need to have a well-crafted Gen AI prompt, right? If you go in and put more or less information or better quality information into your prompt, you're going to get a better quality output. This is the art of generative AI knowledge in terms of your own professional knowledge about using these tools for teaching workflows. It really just comes down to the prompt, and we're going to show you how to unpack that. All right, so when we talk about a well-written learning objective, we're talking about the ABCD model. Now, there's other models you can look at for learning objectives. This one's probably the most well understood, and I'm going to use the color coding from these charts in other slides here to orient you to where those elements are coming up, and so we understand where they're coming from. And so there is the audience, like who is this learning objective? Who are we assessing? Who is actually the learner in this equation? You know, what are what do we want them to actually do for work? In this, what's their condition? We want them to be able to actually do and exhibit a specific behavior and to a certain degree or for the outcome. And so in terms of quality of their response, or that the response includes certain things. We're going to bring this into the MATLAB world in a second. I think it'll be a little more clear for you. And then for the prompt, there are some emerging frameworks about what goes into a good prompt, and there are many out there. And I just chose this one because I think it works really well with the ABCD model, and it shows you how these two things work together. And this example, I'm not personally a Justin Bieber fan. I just want to point that out there. This is the example I found on a website and a blog where they absolutely were Justin Bieber fans, and they have a couple of dogs. And so you can see here that when you're talking about a prompt, there's the format, like what the output is that we're looking for. What do I want the prompt to generate? Reference based on what existing artifact or thing we already have. And in our case, that's going to be the learning objective, and we'll talk about that. Using those things and then context. Now, what is my request? I want you to change it, do something with it, generate it a certain way. So there's going to be a lot of detail in what I want the prompt to do with that context and reference. And then there's framing. It's the additional context and information that kind of fills in the details. It makes sure that if you want certain things to appear or not appear in the output, that you call them out explicitly is what you want. And so I've included some links to sources here for more information about these two structures, but let's go into the actual reality of what this looks like. So I want to have a couple of existing learning objectives. I'm going to go through these pretty quickly. These should be pretty common to you if you teach a course with MATLAB. I pulled them right out of generative AI as well, and we'll talk about that. So there's two objectives I want to go through. The first is for MATLAB scripts. So here's an example of a learning objective of what a MATLAB script might look like. Here's the ABCDs. In this case, it's first-year engineering students. I want them to do some sort of program flow control with conditional statements and loops. I want them to be given a problem description without a coding template. So I actually want them to write this all from scratch. And the degree that I'm going to measure is I want to make sure that that program runs correctly for a variety of test cases. So this is just sort of that learning objective, and then put that all together. Here's sort of what it looks like, and I'm keeping the color coding intact so you can see how the ABCD really works. And so that learning objective is pretty common for what you might expect. Notice it actually calls out using if and else and for loops. Now we also you could ask students to do code in the form of a function in MATLAB Grader. And for that, the ABCDs are a little different. And in this case, I want the behavior to be different. So the audience is the same, behavior is slightly different. Instead of writing conditional statements for control program flow, I want them to actually define and call custom functions with inputs and outputs. See the difference between scripts and functions. The condition is a little different because they're going to be testing their function with a different sets of inputs, so that's important to call out. And very similar degree, the function needs to be able to handle edge cases and pass all the provided tests. So that's the learning objective, and here's what that looks like fully written out. And what's also great, I want to point it out here, if you ever need help writing learning objectives, MATLAB Copilot as a generative AI tool can help you write good learning objectives. You can have like a conversation with it and tell it what course you're authoring and what you're a student, give it all the ABCDs that you might need, and it'll help you create learning objectives as well. It loves talking about MATLAB syllabi and learning objectives, just like code. And so I would encourage you, if you want to create more examples, you can absolutely use GenAI for that. Also, you don't have to use MATLAB Copilot. You could use ChatGPT. I've included a link here, and this will be available in the chat. It'll also be available on in the slides when you receive them for examples of how to create more learning objectives. So here's our learning objective. I'm gonna stick with the one around functions because it's gonna sort of lay into the rest of the features I want to show off in MATLAB Copilot. And so our learning objective becomes the reference for our GenAI prompt. And put this way, that goes into this type of a MATLAB Copilot prompt. And so the format is likely going to be the same every time you would use this prompt. And all it is saying is that I want a MATLAB skills assessment using MATLAB Grader. If you start your prompts with those few words, you will likely get almost all the building blocks you need with very little extra effort to copy and paste the output into MATLAB Grader. That sets it up, and we'll talk about why that works so well in a couple more slides. The reference is simply the learning objective. So that uses this learning objective, and then you just put it in quotes. MATLAB Copilot Chat lets you do multi-lines with blank lines and line breaks for readability. It also, you can copy and paste from a Word document, or actually you can even copy from a live script text box. So if you do all your pre-editing and writing of the prompt, and you save that prompt in GitHub with your assessment items that come out of it, it works great for configuration management. You can just sort of do some copy paste. In this case, I want to dig in a little bit more detailed. So the request is, I want them to actually make sure that the function that we use for this assessment is based on the concept of converting Fahrenheit to Celsius. This is where you bring in the academic discipline a little bit. I'm using a very basic example because I want this to work for the demo that most people can understand. But that request is where you go from, well, the learning objective really ties it off to your academic content. The request is where you get specific about what specific example or academic discipline or real world project do you want to reference it to. The framing is where we actually get into what I want the output to look like specifically. So in this case, I want to make sure that MATLAB Copilot creates a function template for the learner to complete, along with generating all the test cases I'm going to need to actually call the function to iterate through all the various inputs that I want to test for the student's work. Excuse me. And this is what we get out of it. And so now I've got that entire prompt that I can copy and paste. Again, I could have edited this or refined this multiple times. I now have this available in MATLAB Copilot, and so I asked MATLAB Copilot to please do this. You can see how I've got quotes around the learning objective. And then it starts doing the work. So MATLAB Copilot immediately comes back, and not only does it give me the parts I'm going to need to reconstitute a MATLAB Grader problem inside that product, it'll explain to me what it's doing as it goes and explain how each piece is going to be used inside MATLAB Grader. So it always gives you the instructions along with the work product. I find it very, very useful that way. And you can even see the assignment objective. It's sort of restating the learning objective in a way that you might want to actually copy and paste to a syllabus. Maybe you want to copy this into the problem description for MATLAB Grader, and then it does the function template just like I wanted. It's got the function handle declaration. It even included that starting content for the comment that works with the help function inside MATLAB. So far so good. It's got a good template. Then it generates a set of test cases, and then it gives some instructions to the students. And this is what you would include in the instructions, would be what you would include in the problem description instead of instructions for the student. And I want to call out a couple things. First off, notice that when it is giving you code to copy and paste, if there is a LaTeX formula or equation that you could drop into MATLAB Grader, it is using the proper formatted strings for equations. So if you're familiar with MATLAB Grader and creating your content, it has the ability to drop in equations in different places. It's actually giving you the code you'll need for that equation. And so it's copy and paste easy to put that content in. Now, let's talk about those use cases. They're not really the best. The reason they're not the best is at this first pass, it didn't do exactly what I wanted in terms of leveraging some of the built-in MATLAB Grader helper functions that you might be familiar with in terms of creating MATLAB code test cases. If you're familiar with our documentation for MATLAB Grader, we have a lot of good information about how to write really good assessment test cases. We actually provide our own custom toolbox, if you will, for all the variable assessments and function presence and writing your own custom MATLAB code. And these test cases don't use any of that. And so that was sort of a flag for me when I'm reading this. Now, I also want to point out to say, using MATLAB Copilot, because it is generative AI, it's not going to be perfect every time you run your prompts and get your output. It's meant to be an iterative process. So let's iterate. So now I want to iterate, and I want to remind MATLAB Copilot a little bit here with a nudge that say, hey, you know a thing or two about MATLAB Grader. These are all MathWorks products. They're all related. MATLAB Copilot has access to our documentation. MATLAB Copilot knows all about the MATLAB Grader assessment function. So I give it a little nudge. And in this case, I say, can you just make sure to change the test case implementation to use the specific functions provided by MATLAB Grader? And then it tells me how I might do that, and it explains what it's going to do, and then it does it. And these are good, right? These are copy and pastable test cases that can go right into MATLAB Grader when you're evaluating students' homework in the form of a function. And what's really great is it then goes into the explanation about why this is even better. It now explains what's going on with the code. It explains what's going on with the test cases. So if you're relatively new to MATLAB Grader, I want to pause and say you don't have to be a professional teacher with MATLAB Grader to start using MATLAB Grader. In fact, MATLAB Copilot should make it even easier, because now MATLAB Copilot's telling you how MATLAB Grader works and how if you were to use these test cases, how they will actually evaluate the student's work. And what I also want to point out is one of the greatest features of MATLAB Copilot for helping you learn more about MATLAB Grader is these follow-up prompts. And you can just click on them and learn about the product. You can learn about MATLAB Grader. You can learn about how it's used. You can see these example follow-up prompts are fantastic for digging in further to illustrate what to do with your function test, how to use the built-in assess variable equals function calls. It'll even, if you really want to educate yourself about MATLAB Grader, keep digging into additional capabilities of the product. So it's a really great feature of MATLAB Copilot. It'll always bring you into that conversation. All right, so that was the overall structure of how to create a MATLAB Grader assessment item using Copilot. Now we're going to talk about some of the more advanced workflows, and one of them is on those unit tests, right? So in the first example I gave you, I asked MATLAB Copilot to generate all of the tests I needed to turn into MATLAB Grader assessment tests. In this case, I'm going to try to create them using features of MATLAB Copilot. And this might be useful because, say you already have the code generated. You don't need MATLAB Copilot to create the reference solution. You already have code. And so in this case, I'm actually going to show you, if I already had code, what could I do to actually do all the additional pieces I need for MATLAB Grader without having to write a really complicated prompt with learning objectives. So this is sort of like the skip ahead, show me the work example. And so just a reminder, when you're calling a function inside MATLAB Grader, you need both the function itself and some wrapper code to call it. MATLAB Grader separates those into two sections. And what you'll find, and I have a really simple prompt here, I'm just asking, I was being very reductive now, without the context of a learning objective. With all the extra trappings for assessment, I just asked Copilot to generate that function for me with one sentence. And it creates basically the exact same thing that I would need as a reference solution. And so here I have the reference solution, and it even gives me example code that I could use to call it. And that's copy and pastable right into MATLAB Grader. But let's go a little bit further. So I want to improve the function. So using the features I showed you earlier, I can highlight the function that was generated by MATLAB Copilot. I can push the button to move that code over into the live script, highlight that code, and then I do my Command Shift P, and I get the prompt right inside the live script, and I ask it, add function argument validation and comments to explain the arguments. And then it added all sorts of different comments, right? So again, we talked about how that's important. So here's the example where I can just right-click, do that. If you have if you want to educate yourself a little bit more about arguments and adding help for the program, I've included some links to doc to explain why that's important. Now, you can also generate those unit tests with a click. So highlight the same function that you already have, save to a .m file. In the right-click menu, you can see here, just highlight, right-click Copilot, and then choose Generate Tests, and out it comes with all these test cases. And what's really brilliant about these test cases is it kind of picked up on the fact that this is temperature conversion, and it knows a thing or two about science in MATLAB, and it knows what the inflection points are. It knows positive, negative temperatures might need to be considered. It knows boiling point, it knows freezing point, and so basically creates test cases for all the pretty much common inputs you might expect for that type of a function. You can also then one-click button run those tests, and you can see here that, yeah, the function as written will work for all of those different outputs. And then it's simply just a copy and paste. So when you're implementing an assessment item in MATLAB Grader, you can choose one or more assessment tests in the format of MATLAB code, and you can move that in. Now remember, you can see the difference here between the left and the right. The left one that was generated, that has that test case unit test framework. The way that MATLAB Grader likes to do that is using what's called assess variable equals. And in this case, the example is I rewrote it a little bit using MATLAB Copilot to actually use the built-in MATLAB functions to make reference to a reference solution and not a static value. And so what's really great about this is that you can use MATLAB Grader to set up your reference solution function, which was generated in Copilot. You can create a learner template that doesn't have the guts of the function, but just the function declaration and some of the scaffolding of comments. And then when you create your assessment tests, you're just basically copying and pasting in different sets of inputs. It runs the reference solution, it runs a student solution, it compares the two of them, and if they're not correct with intolerance, it will actually send a message to the student that's written here, which is check that you've entered the equation correctly. And so if you want assistance in writing any aspect of MATLAB Grader items, you can have this interrogated sort of conversation with MATLAB Copilot to improve upon what you put into to MATLAB Grader. Now, if you're looking for additional inspiration of content, lectures, notes, assessment items that are already off the shelf, we have lots of examples. One of those example things I want to point out for you is what's in our courseware website. And I have a link here. This is sort of a very small snapshot of what's in our courseware collection. They're all available on File Exchange and GitHub. And so with one button click, you can open these examples in MATLAB Online, be dropped right into the example and be looking at what the content is. And I wanted to show you an example of converting content from off-the-shelf assessments you already have that maybe students saw last academic term and you want to update them for academic integrity purposes, right? And so I want to start with a known good example. And I didn't want to create it myself. So in this case, I went to the MathWorks website and I downloaded and cloned a repository on transfer functions. And so I am now in this sort of academic domain of thinking about transfer functions. And there's lots of examples. Like I think the most commonly recognizable example of that is like a mass spring damper, or maybe a pendulum, or maybe a RLC circuit. And so I have all these things in my mind now about different ways I could interpret that. But last year's assignment was specifically focused on mass spring dampers and pendulums, and I want to do it a little differently this time. And so using MATLAB Copilot, you can actually reference an example from content you already have, or that you found on our website, or that you found from a colleague, and you can ask Copilot iteratively to modify it and change it and turn it into something new. You can also, if you find a set of prompts that work really well for your content, you can save them and version control them and always go back to them every academic term and basically swap out the content, but keep the learning objectives the same. And I think that's the point. Like, you want to make sure that it's consistent with your syllabus and your learning objectives, but it just creates new content that the students haven't seen before. And so that's really what we want to do. We want to stay inside MATLAB the entire time for doing this. So here's what it looks like. So the first thing I might do is find another exercise. So here's a screenshot from that courseware example. In this case, it's about finding the transfer function of a pendulum with 0 initial conditions using a set of equations. And you can see here, this is a live script I can open this example in MATLAB Online and immediately get content I can use. I copy that content inline to my prompt, and I ask MATLAB Copilot to update this example, and I actually got it wrong. I was in the mindset I was thinking mass spring damper, but this example is about a pendulum. But I included this in the slide to show you that MATLAB Copilot's pretty robust in terms of catching these sorts of mistakes and errors instead of understanding what you meant and what the interpretation was. So in this case, it says, okay, yes, here's what I want. I want to convert this into an RLC circuit, but keep the same learning objectives, right? And then I copied and pasted the exact content of the example that I had found. And then Copilot comes back with a rewritten example. And it's basically saying, yeah, let's do it as the form of an RLC circuit. Notice again that it does really great latex equations. I want to point out here just a plug for this whole workflow. If you're doing any sort of advanced math inside MATLAB and using live scripts, you really probably like the inline equations and everything. If you're using MATLAB Grader, you need to move those equations into the special format that we have in the live editor that's part of MATLAB Grader. What's awesome is that when you're talking to MATLAB Copilot about math that involves both the symbolic math toolbox and latex equations, it's like some sort of superpower. It gets it right. It does the formatting right. It really uses all the right ways of using symbolic math. It might even apply systems of units for symbolic math. And so it's a really great way of looking at some more complex math here. And so this example is really great. It's like the same learning objectives, but in a completely different project discipline. And so you can just update your content with a prompt, and it's really that easy. You can also do this with other programming languages. And so these screenshots I actually took right out of ChatGPT, because what I did is I went to ChatGPT, and a lot of you have access to ChatGPT, so you might not have started in MATLAB Copilot, particularly not for Python code. So maybe you created some Python-related assessment content, and it's just hanging out in ChatGPT. And here's an example of a conversation I had, and I include a link to my full conversation about how I created this content. So I created a Python example from scratch. In this case, it's just doing the other learning objective that we talked about earlier in today's presentation. So now it's digging into a MATLAB script and is showing what that implementation of that learning objective might be in a Python world. That's really all this is. I don't know anything about Python programming other than to say, I know this code executes and it does pretty much what I asked it to do through the learning objective. So starting with a programming assignment in a different programming language from a previous academic term, how do we go from this and make it MATLAB? It's pretty simple. And you can do this all inside MATLAB Copilot. So the first thing you do is just ask the question. In this case, I actually started with a blank live script. I hit Command-Shift-P. That's my pro tip. Command-Shift-P. I'm a Mac user, so I'm going to say Command-Shift-P. If you're on Windows, I think it's Control-Shift-P. That's our new shortcut for Copilot inline prompting. And so I start with a blank sheet, and I can Command-Shift-P, and I say, convert this Python code to MATLAB. That's the prompt. And then I paste from my Python code right below that. And then I hit submit, and then it generates perfectly good MATLAB code right there, and I can actually run that code, and it works just fine. The next thing I want to do is turn that script into a MATLAB Grader assessment. So all I have to do is copy all of that wonderful code that was just converted from Python to MATLAB, and then throw it in the body of another prompt. And this is a prompt I like for examples when I already have the code written. I don't need Copilot to write the code. I just need it to do all the assessment stuff. And so the prompt is very simple, using the following live script to make a MATLAB Grader assessment, provide a problem description, learner template code, and reference solution. Give assessment tests that check the learner that both use, and this is where I get into the degree thing of the ABCDs. Check that the learner used both the while loop and a for loop in their solution. So there's two examples, two implementations, should have the exact same output, but they're implemented both with a for loop and a while loop. And so I ask it to create the item. And so here it goes piece by piece. This is what's brilliant about this whole workflow, and this is really, I'm going to kind of sort of stop today's webinar, I think, is it generates everything in the order you need it with instructions on what to do. And so it generates the problem description for the students, the learner template, the reference solution, the assessment tests, and it also gives you all the help on how to implement that in MATLAB Grader, right? So that's the point, is you have this wonderful tool in MATLAB Copilot, and you have this wonderful teaching tool in MATLAB Grader. Let's put them together and help you save time creating assessment content.